Welcome to Class 8, Mathematics Chapter Power Play. Imagine counting every single star in the universe, one per second. How long would that take? And what if you tried to drink all the water on Earth? Let us use the power of scientific notation to find out. We break down questions step by step to help you understand better. Hit like and subscribe to support the channel. Before we dive in, let us recall two amazing facts from our chapter. There are roughly 2 times 10 to the 23 stars in the observable universe, and there are about 2 times 10 to the 25 drops of water on Earth, assuming about 16 drops make 1 milliliter. Remember, scientific notation means writing a number as a times 10 to the n, where a is between 1 and 10. Part 1. If we count 1 star every second and there are 2 times 10 to the 23 stars total, then the rate is 1 star per second. The total number of stars is 2 times 10 to the 23. Time equals total divided by rate. That is 2 times 10 to the 23 divided by 1. So the time is simply 2 times 10 to the 23 seconds. The rate of 1 makes this direct. The number of seconds equals the number of stars. Now part 2. This one is trickier. We need 3 steps. First, convert drops to volume. Then volume to glasses, and finally glasses to time. Let us go step by step. Step 1. We know there are 2 times 10 to the 25 drops of water on Earth, and 16 drops make 1 milliliter. So the total volume in milliliters equals total drops divided by 16. That is 2 divided by 16 times 10 to the 25. 2 divided by 16 gives us 0.125. But wait. Scientific notation requires the coefficient to be between 1 and 10. 0.125 is less than 1. So we shift the decimal one place right, 0.125 becomes 1.25 and the exponent drops by 1, 10 to the 25 becomes 10 to the 24. The total volume is approximately 1.25 times 10 to the 24 milliliters. Step 2. Each glass holds 200 milliliters. Let us write 200 in scientific notation, that is 2 times 10 squared. The number of glasses equals total volume divided by 200. Now we divide. 1.25 divided by 2 gives 0.625. And for the powers, 10 to the 24 divided by 10 squared is 10 to the 22. Once again, we need to fix this. 0.625 is less than 1. We shift the decimal one place right. 0.625 becomes 6.25 and the exponent drops by 1, giving us 10 to the 21. So that is 6.25 times 10 to the 21 glasses. Final step. Each glass takes 10 seconds to drink. So total time equals number of glasses times 10 seconds. That is 6.25 times 10 to the 21 multiplied by 10, which is 10 to the power 1. Adding exponents, 21 plus 1 is 22. So we get 6.25 times 10 to the 22 seconds. For our answer in clean scientific notation, we round this to approximately 6 times 10 to the 22 seconds. And here are our answers. It would take 2 times 10 to the 23 seconds to count every star, and approximately 6 times 10 to the 22 seconds to drink all the water on Earth. These numbers are so enormous that they are beyond human comprehension. That is the power of scientific notation at work. Here is the method you can reuse for any problem with large numbers. Step 1. Identify what is given, rates, totals, conversions. Step 2. Set up your calculation, divide or multiply as needed. Step 3. Compute using scientific notation rules, divide the coefficients, subtract the exponents. Step 4. Always normalize, make sure your coefficient is between 1 and 10. That last step is the one most students forget. Always check, is your coefficient between 1 and 10? Scientific notation does not just save us from writing zeros, it lets us grasp quantities that would otherwise be beyond human imagination. From the stars above to the oceans below. Keep learning and keep growing. See you in the next question.